Hi everyone, this is going to be our note for 4.5, and this is actually going to be our last lesson for this unit. That's because there is 4.6 in the textbook, but due to us not being in class, we have to make some cuts here and there, and I was even debating doing this one, but on your assignment, you're going to get some word problems, one or two, so I actually want to go over some of these with you because it'll help you for your Chapter 4 or Unit 4 final assignment. So here's our note for 4.5. We're going to be solving problems given quadratic equations. So we're just going to get to examples that you might see in your textbook, you might see in your assignment, or very similar to that. And we've done enough of these in our notes and hopefully in the textbook, but in our notes alone, where we're seeing a lot of the same ideas, a lot of the same words used over and over again. So we're just going to confirm those words and what they're asking for, and then you'll be asked to do that yourself. So for example 1, a ball is thrown upward from the balcony of an apartment building and falls to the ground. The height of the ball, h meters above the ground after t seconds, is given by the function this. So the h at t here represents the height. And the equation just represents the height at different t times. So determine the maximum height of the ball. Which form of the equation would be helpful here and why? So what word do we see in this first part A that they want us to answer? We see this word that we've seen time and time again. The word is maximum. Determine the maximum height of the ball. We should know by now, hopefully, if we've done all our homework and if we understand the concepts from our lesson so far, that when we're talking about the maximum height, we are looking for the correct. Thank you for yelling it out. And if you weren't aware of that, again, got to review some of our notes or arrange some office hours so we can go over these concepts. So we need to determine the maximum height, which is always the vertex. And why is that? Well, whenever I get a word problem, I just like to draw a diagram just to make myself feel like I understand the question a bit better. So here's my apartment. Just a sketch, it's not very good. Here's the balcony. Only this one person gets a balcony. And they stand here. They throw their rock up, and then it comes down. And then the ground is here. So this is what they did. They threw the ball upwards from the balcony of the apartment building, and then it fell to the ground. So the maximum height has to be the point where the ball reached the highest. And since it was thrown upwards, if it goes up, then it has to come down again. So that maximum height has to be when it was thrown up before it started to come down again. So which equation would help us find the vertex? Well, we did learn we could use any one of these, but one of these is easier than the other ones. So obviously that one is going to be, which form? Vertex form. Because I want the vertex, I'm going to use my vertex form equation. So now we need to start connecting ideas between our different forms of the equations. So like what form of the equation is it in originally? Our ht equals negative 5t squared plus 15t plus 45. What form is this equation in? Well, this one is, out of these three, we find that this one is in standard form. I don't see any brackets, there's no factors for factored form, and it's definitely not in vertex form, or else we would know the vertex already. So this is in standard form. So how do I go from standard to vertex form? Well, I'm going to have to do this thing called, which we learned before, hopefully you're telling the screen you learned about, completing the square. This technique we had to practice a few times because now it's showing up and we have to be able to do it. Hopefully not having to look at our notes, but again, if you're doing an assignment and stuff, you have your notes with you, so use them to help you out. But this is our technique. I'm going to get my equation in standard form. And our steps are, first step is to common factor the first two terms. I get t squared minus 3t plus 45. So I just divide the first two terms by a number. In this case it was negative 5. So I'll zoom in here. It's a bit easier. Ooh. There. So we had to common factor out the number just for the first two terms. And then I'm going to get my middle term here, the one, the negative 3 here, and I'm going to perform that thing where I have to divide it by 2 and then square it. And if I do that, I get 1.5 squared, which is equal to 2.25. So then I'm going to get this value, and we're going to add to it inside the brackets and subtract from it inside the brackets. And the outside is still the same. So we added and subtracted this inside the brackets. Sorry, this number that we had here. And we got this from getting the t term, or the middle term, that was in our thing here, and we divided it by 2 and squared it. Then our next step was to move the subtraction one outside of the brackets. And when I do that, remember I have to multiply it by the coefficient in the front. So when I do that, my next step will be -5 t squared minus 3t plus 2.25. The 45 is still there, and I move this out and I times it by -5, and when I multiply those together, I get 11.25. So I'm almost done. I just have to simplify now. I know that this is now a perfect square. That's why we did all of this work. So all I have to do is know it's going to be something squared. I know it's going to be my variable. It's a minus here, so it'll be a minus in here. And I know I can figure out this other value by either square rooting this or dividing this by 2. It's going to be 1.5, and then we add these together, and we get 56.25. I apologize for the glare. I just want to make sure that it's you can see the work. But the main thing is, I hopefully didn't go too fast. I might have gone a little fast. Honestly, you maybe had a little bit of trouble with the vertex or completing the square, and you had some questions about it. But at this point now, hopefully we can perform it pretty accurately and pretty quickly. If not, again, we might need some more practice, or when you're doing your assignment, refer back to your notes to make sure you're filling out the steps correctly. So this is our equation now in vertex form. What is the vertex? Well, our h and our k values are our vertex in vertex form, or the x and the y values. So I have this and this. So my coordinate is 1.5, 56.25. So again, looking at our diagram, this really is just a Cartesian plane if we just do this. So this represents our y value, the height, and the bottom represents the x values, which is our time. So what is the maximum height of the ball? The highest point has to be the y value of our vertex, which is 56.25. So therefore, max height is 56.25 meters. I would write a better sentence, but I don't have a lot of space. It's for your notes, so it's okay. But test or assignment, I should write a better sentence. The maximum height of the ball when thrown is 56.25 meters. Now, how long does it take the ball to reach its maximum height? Well, if we're measuring time now, how long does it take? This refers to time. So when does this happen? Well, that's just the x values of our vertex. And they said t is measured in seconds. So our answer here is going to be how long it takes. Therefore, it takes 1.5 seconds to reach max height. The max height, sorry, I should try to be better. Sorry if my printing is a little bit sloppy. I'm trying to be I'm trying to make the videos a bit faster, as long as you can read this. So I'm sorry if this is messy. I want you to read the calculations. Okay, so how high is the balcony? So which form of the equation would be helpful here and why? So this is one that always I find tricks the students, but I think it's just hard to remember. But how do I know how high the balcony is? Well, when is the ball on the balcony? The ball is on the balcony when the person hasn't thrown it yet. So we can write, just as a reminder, when the ball is not thrown, it's on the balcony. So when is the ball, at what time is the ball on the balcony? How much time has passed? Well, if it's still on the balcony, it hasn't been thrown yet. The timer starts when the ball is thrown. So if it's still on the balcony, time, which is t, is equal to 0. Because no time has happened yet. The person is still holding the ball. So which form here is helpful? To be honest, anyone would be helpful, because we just have to make t equal to 0. So usually I'd say it's the one that they give you the equation in. And in this case, standard form I'd say would be the easiest as well, because we don't have to manipulate anything. But also, if we're making t equal to 0, we'll see. Just let me write this out, or so you can write this out as well. That if I make t equal to 0, oops, there's a t there, times 0 times 0, the only thing I'm left with is 45 here. So the height of the balcony has to be 45 meters when no time has passed. So this one's easiest because it just becomes zeros, but either one of these is also, you could use any equation or any form for what you think will be easiest for you, but in this case I think standard would be the easiest. This is an excellent question that you would get on a test if we were having tests, and people would just say, I don't know, and you would give up before you give this a shot. So let's go over it, because I don't think it's that bad. What do they tell us? What do we know from the question? Well, we know the revenue is represented by this equation. I'm just going to write this equation out. Just want to get all my ideas out in front of me so I know how to attempt the question. That's our revenue equation. We know X is the number of 10-cent increases, and RX is the revenue in dollars. What should the price of tickets be for the company to earn this much? So they want the revenue to be $21,000. So they want to know what is the ticket price for them to get a revenue of $21,000. So if they want to know what the ticket price is, what we have to do is we need to solve for X. We don't know what X is. And we're looking for X when RX is $21,000. Sorry, I just wrote the letter R there. You didn't miss anything. I really don't want to go back and edit it, so I'm very sorry. It's just letter R. So we're trying to find what is X when the revenue is $21,000. So what do they mean by X is the number of 10-cent increases? Because, well, how much is a ticket first off? It says a ticket is $2. So if they're saying, I was going to write this on the side here, just like to be a little organized. If they're saying X is the number of increases, it says increases by 10 cents. So if they said X is equal to 1, what is the price of a ticket going to be? Well, the ticket is usually $2, but with one 10-cent increase, the price is now $2.10. Because you can think of it as X is, well, if X is 1, then it's going to be 10 cents. Oops, sorry, I just wrote that wrong there. X is 1, and every increase is 10 cents. I wrote that. Is 10 cents. So if X is equal to 2, we can say the price would be, well, we're adding 20 cents now, would be $2.20. And if it was 0 increases, what would the price be? Well, it would be 0, because we haven't increased it by anything. And what if it was 5 increases? Well, 5 times 10 cents would be $2.50. So in this scenario, we're trying to see, well, if I raise the price of some of our tickets by a certain amount, what is the revenue that we're going to get for that? And I want to figure it out for $21,000 as revenue. So we're going to solve for x. Whatever we solve for x going to be, whatever we solve for x to be, we're going to add that to our $2 to get the price. So now let's actually get to the question. We've listed all the things we know, and we listed this just to show our understanding of the question. So I'm going to start with my equation. Rx equals -40 x minus 5 squared plus 25,000. So what form is this equation in right now? Hopefully we can recognize it by the way it looks. Hopefully you're yelling at your screen or phone or whatever you're watching this on that, oh, I see an exponent here, this has to be vertex form. So we're going to be manipulating vertex form here. I'm going to put Rx is equal to 21,000, and I want to figure out what is x going to be in this case. So I could do a number of things here. I could turn this into factored form or standard form if I wanted to, and then maybe did a different method of solving for x. I could have used a quadratic formula or something. But in my mind, vertex form is easiest here, because all we have to do is just solve for the x here, and we have enough to work with that we can just use our bed mass to make it pretty easy, or reverse bed mass in this case to isolate. So first thing I'm going to do is I want to get the x by itself now. So I'm going to move this to the other side first. We always do our addition subtraction stuff first. So it becomes 21,000 minus 25,000 equals -40 x minus 5 squared. We get -4,000 is equal to -40 x minus 5 squared. Then I want to get this by itself again. I notice I have a factor. I'm going to divide both sides by -40. I get x minus 5 squared. Oops, just going to move this up. And then -4,000 divided by -40 gives me 100. Now I want to get the x by itself, but I have this squared around it, so I'm going to do the opposite of that. Square root. I get square root of 100 is 10. X minus 5 is this. I want to get the x by itself still. We've done everything around it so far, so the only thing left is this one. It becomes 10 plus 5 is equal to x. So 15 is equal to x. So we did it. What should the price of tickets be? $15. No, that's not the answer. Remember, we said x is the number of 10-cent increases. So we have to apply our method here for what we have here. So what if x was equal to 15? Well, the price would be 15 times 0.10, which is $1.50, which means we add $1.50 to the $2, and we get $3.50. So what should the price of tickets be? Therefore, tickets should be $3.50. Alright, well that last example was pretty fun, but let's get to a slightly more challenging one. I don't think it's more challenging, I think it just looks more challenging, but it's kind of the same ideas. So example 3 says, the stainless steel gateway arch in St. Louis, Missouri has the shape of a catenary, which is a curve that approximates a parabola. Basically, it's just like a big curve. If the curve is graphed on a grid with the origin on the ground directly below the top of the arch, the curve can be modeled by the function, this equation, where h is the height of the arch in meters, and d is the horizontal distance from the vertex of the arch in meters. Sketch the shape of the arch, label the key points. So when you're saying a catenary, I'd be surprised if you've seen this word before, because I don't see this word very often. All it really means is it's going to be a curve. So if I had to kind of sketch an approximation of this, it's just a parabola. It's going to be a curve. I could Google it, but for the sake of my question, it's going to be something like that. Is that perfect? No, it's not very great. But it gives us an idea for what we need for our question. And they said specifically that when the curve is graphed on the grid with the origin on the ground, directly below the top of the arch. So the top of the arch is above the origin. So this has to be the maximum point. So this is the vertex. And what would these points be? This would be an x-intercept or a root or a solution. And we can label this the origin if we want to. The main things are the vertex and the x-intercepts. So we labeled the key points. Find the maximum height of the arch. Well, let's take a look at our equation here. 0.02 d squared plus 192. A couple things we can get from this equation. First off, what is the horizontal distance at this point? Well, they said the maximum height of the arch occurs at the origin. And what's the x value here? Or in this case, we're saying our x values are the d values and the y values are the h values for height. What is the horizontal distance of our maximum point? Well, this occurs when d is equal to 0. So if I said d equal to 0 here, I would just get 192 meters. Just for your own kind of interest as well, this isn't part of this, but I'm just going to do it over here. This equation is actually can be viewed in a couple of different forms. This is technically in vertex form as well. Oops, I'm just going to move this over, maybe zoom in a bit. Plus 192, except we just don't have any brackets around here. But this is kind of the same as saying d minus 0 squared plus 192. So here our x value of the vertex is still 0. So it's just another way to get our vertex. So again, this looked like a very weird equation because of our decimal here, but once we analyze the question, maximum height is being the vertex again. And once we knew the vertex is above the origin, we're able to figure out the answer. Find the approximate width of the arch base. So the width of the arch base, meaning what is the width from this part of the curve to this part of the curve. So if I know two values, these x-intercepts, and I know that the x-axis, or the letter d for the x-axis, is the horizontal distance from the vertex of the arch in meters, if I can figure out these points, I can know the distance from here to the origin. So to find the approximate width of the arch base, I'm going to have to look for the x-intercepts. And for us to do that, well, what is the height for our x-intercepts? We have our x-intercepts here. Sorry, I made these lines just to show a scale, but like when we're finding the x-intercepts, they're still coordinates. I'm still using the coordinates. So the height at these coordinates is 0, because at these coordinates there is no height on the arch. So we're going to set h equal to 0 in our equation. First I'll rewrite it. Then I'll set h to 0. And like before, I'm just going to solve for what the letter d is going to be. So first thing I'll do is, if I want to, I can move either one of these. This one's negative. I'll just move this to the other side. I get 0.02 d squared equals 192. I'm just going to move this over here. Why didn't I just write that there in the first place? I don't know. I wish I had a better answer for you. Good question, though. Thank you for asking. So I want to get the letter d by itself. I'm going to divide both sides by 0.02. And then when I divide these two numbers, I get this number. And then I want to get the letter d by itself again, so I see squared The opposite of squared is square rooting. So I get this is equal to 97.98. But not just 97.98. Remember, when we take the square root of a number, it can either be a positive or a negative number. So there's two possible values, negative 97.98 and 97.98. Now, does that make sense for our question? The answer is yeah, because if this is the maximum point and these x-intercepts are always equal distance from the vertex, that means that this has to be negative 97.78 and this one has to be positive 97.98. So what is the distance between these two? Well, if these are both 97.98, from here to here is 97.78, sorry. Oops. 98, I apologize. If the distance from here to here is 97.98, and the distance from here to here is 97.98, if I add those together, or I times it by 2, I'll get the distance of the whole width of the curve. So I'm going to get that times it by 2. I get 195.96 meters. So that is the width of this. By knowing my two x-intercepts and the distance from here to here, I just add them together. Find the approximate height of the arch at a horizontal distance of 15 meters from one end. So now they're giving me the height, or sorry, they want me to find the height after giving me a horizontal distance of 15 meters. So what variable did we say represents the horizontal distance? Looking back at the question, the horizontal distance is represented by the letter D. So we just had to read the question. This is the letter D. They're saying, well, what is the height when D is equal to 15? Remember, height is h. So just reading this question, this is like a 1-mark question of just what's the height if this is this? We just have to solve for h and make D that value. D squared plus 192. We're going to make D equal to 15. And then we get 187.5 if I do all of this. So the height is 187.5 meters at 15 meters. Now what does this mean? Well, if I have a horizontal distance of 15 meters, that's like over here. Oops, I'll do it over here. The height of the curve is like here, which we're saying is about 187.5 meters. Oh boy! All right, one more to go. Again, a reminder: you can, do these in different intervals if you want. You can do you have to watch the whole video in one day. I advise you to, but you don't have to. Our last example is a little bit tougher, but we just have to do some extra work for it. So research for an orchard has shown that if 100 pear trees are planted, then the annual revenue is $90 per tree. If more trees are planted, they have less room to grow and generate fewer pears per tree. As a result, the annual revenue per tree is reduced by 70 cents for each additional tree planted. The revenue, in dollars, is modeled by the function this. No matter how many trees are planted, the cost to maintain each tree is $7.40 per year. The cost in dollars is modeled by the function this. How many pear trees should be planted to maximize the orchard profit for 1 year? So when we get to a question like this is usually when I hear the sir, these questions are too hard. Why do we have to learn these questions? I just want to bring up that in grade 9 we gave you word problems, and then some of the complaints were, sir, these are too easy. When are these going to ever come up? Well, now we're in the kind of a middle ground of, well, what kind of questions do you want? I'm trying to let you know that the problem is that people just don't like word problems. It doesn't matter what the level is. It doesn't matter how complicated or simple they are. People just don't like word problems. But we need to get over that. We need to work and do more of them so we can get better at them. And of course, set up office hours with me if you're really struggling with them so we can go over them together. Because the last thing I want you to think is that you're alone in doing these kind of things. Especially now. You can always have support. So please let me know. So what do we have to do here? We have to know, well, one thing beforehand. Well, what does the question want? Obviously, any business, they want to maximize the profit. That's what everyone wants to do if you own your own business, because you want to get the most money. So in order to do this question, we have to learn about profit. The profit equation, profit is the revenue subtract the cost. So the revenue for your business represents how much money have you made. So if you're selling pears or pears from pear trees, your revenue is how much money you get from selling them. The cost involves, well, how much does it cost to maintain each tree? And maintaining a tree might involve a number of things. Might be fertilizer or food for the tree. Might be when you're watering it, you're putting different chemicals in to help promote better growth, making sure the tree is healthy. Maintaining a tree might be paying other people to help you run the farm or to gather the pears. So there's a lot of costs involved in a business. So how much money you profit or how much you gain from the business is how much money you make, subtract how much you have to pay to maintain the business. So if people didn't know that, now you know that. You might need this for some of the homework as well. So for me to figure out the profit, to maximize the profit, well, if I'm doing maximizing stuff, we said the maximum is always the vertex. So I have to find the vertex for the profit equation, which is going to be P at x. So now I'm just going to substitute what R at x is and what C at x is. So we said R at x is this equation. So I'm just going to substitute the R at x with this equation. 100 plus x times 90 minus 0.70x. And then we're going to subtract from that the cost equation, which is this. 7.40, 100 plus x. So we're going to subtract these two equations, and I want to put it in vertex form. So in order for us to do this, we're going to have to first expand this and then use distributive property here. So doing this times this times this, I get 9,000 minus 70x, and then this times this times this, plus 90x minus 0.70x squared. And then I'm going to distributive property of this. I get negative 740 minus 7.40x. Oops, forgot the x there. Then I'm going to just collect my like terms. Negative, I have to put the highest, well, you should put the highest exponent variable first, so the 0.70x squared. These two are like terms. They're going to simplify to give me plus 20x minus, oops. That's what happens when you go a bit too quickly. Sorry, just erase that. So we did this one first, and that's why I didn't underline this to organize my ideas. We had this first, then we did these two, and we got a minus this from it. So I'm just going to erase that, and I'm going to change that now. So 20x minus 7.4 will give me 12.6x. Again, I'm just collecting these like terms. Negative 70 plus 90 minus 7.4. Adding all these will give me 12.6x. And then I'm left with negative 740 and 9,000. Collecting those like terms, I'm going to get positive 8260. So from here to here, sorry, from this step to this step, I'm just collecting my like terms. So after I've collected my like terms, well, I got to put this into vertex form. How do I put that into vertex form? We have to, back to the beginning of the note, we said to put something in vertex form, we have to complete the square. As you can see on the page, I do not have room to complete the square. So after we complete the square, though, to get it in vertex form, I would get P at x is equal to negative 0.70 x minus 9 squared plus 8316.7. That's very hard to see. I'm going to erase that and then write it out nicer. And normally I'd pause the video, but this video is already pretty long, so I'm just going to do this. And I'm going to zoom in a whole bunch. So we get this. This is our equation. So my vertex, if you're like, I can't read that number, 8316.7, which would be right there. That's what that number is. So this is my vertex. So what is the maximum profit for 1 year? And how many pear trees should be planted? So this is going to be, this is how many pear trees should be planted, and this is their maximum profit. So if they have 100 pear trees in the beginning, and then we're going to add 9 to it, so they should plant 109 pear trees, and their maximum profit will be $8,316.7. All right, thank you for your patience in this. I know the word problems get kind of tricky. If you need help with them for the homework or for your upcoming final assignment, please let me know, give me a message or an email, and we'll work out some office hours so we can go over these questions. Thank you very much for your time.